Hi, welcome everyone. Welcome to today's DevOps.com webinar. We're talking about the state and the future of cloud databases. A great topic because database is always one of the challenges about how we think about the data and databases in the cloud and on-premise and both. My name is Mitch Ashley. I'm CEO of Accelerated Strategies Group, an analyst firm covering this space. I also work as CTO with MediaOps, the folks that are hosting our webinar today. Let me cover a few housekeeping items, and we'll get right to our conversation. And just to give you a heads up, we aren't doing slides. We're not going to bore you with that. We've got a great topic teed up and a great speaker, a great guest today. So a few things housekeeping wise. We are recording the webinar, so sit back, relax. You're welcome to take a few notes, but you'll also have an email after the webinar with a link to the recording and no slides. So the good news there. We're also giving away 4 gift certificates at the end of the webinar. So stick around and find out if you're one of the winners of an Amazon gift card. So we love questions, by the way, and this platform that we do our webinars on, called Big Marker, is a great place for conversation. And frankly, the best webinars and roundtables that I'm on are the ones where the audience is a big factor in that. Sometimes, matter of fact, it drives and shapes where we take the conversation. So I highly encourage you to comment, ask questions. You can put them in the Q&A tab. You can type something into the chat and do it that way. So I'll definitely be engaging folks now. We have a few kind of poll questions that we're going to be asking folks to join in. So let's get to our content, the state of and future of cloud databases. Great pleasure of introducing my co-speaker today, Jim Walker. Jim is Principal Product Evangelist with Cockroach Labs. Welcome, Jim.
Hey, Mitch, how are you? I'm happy that you presented me as a co-speaker because y'all, our host, knows a whole lot about this topic as well. So I'm excited to get into this, Mitch.
I am too. And our kind of prep call for this just got me even more excited about, okay, I know we're going to have a lot of fun here talking about this. Let's start with, and I'll take down the slides so we've got our videos up there. Would you give us just a little bit of your background and introduce yourself, and then also tell us a little bit about Cockroach Labs?
Sure, you bet, Mitch. Undergrad, going all the way back to the TI-99 Commodore 64, I've been coding my whole life. I coded professionally for about 7 or 8 years. And I actually ended up in marketing because I got really frustrated with salespeople, Mitch. Every time they opened up their mouth, it added like 3 or 4 weeks of scope to our project. So I ended up being the person that just went in front of people to just explain what was going on and kind of validate what people were asking to do. That's when I coded. And then, I naturally just kind of ended up in ISVs. And I'm kind of a startup junkie since then. I've been building kind of category creating companies really for the past, quite a while in security and then mostly in data. Although I did kind of dip down into orchestration. I was at, Gaussian data was, initiate systems and MDM. It was Talend and data integration and data quality. It was Hortonworks and Hadoop. It was, and then I kind of dipped down into the infrastructure and went to CoreOS and messed around with Kubernetes and got introduced to distributed systems. And now, Cockroach Labs, which is a fairly unique company in that what we're doing here is basically re-architecting the database for kind of these modern workloads and the modern infrastructure that we all live on today. Just taking the database and reinventing it so that it is distributed and is going to provide all the value that we've thought about in the past, yet the scale and the resilience and the ubiquity of the cloud. And so that's how's that? It's like about a minute and a half. I don't know. It's not so bad.
I think
it's a lifetime of stuff.
Used our time effectively. Well, let's start the conversation this way. In my own journey to the cloud, you kind of experienced this. Let's take what we currently do, move it onto a different platform. In this case, we put it up on the cloud, show the lift and shift strategy. And I know many folks have done that with databases as well. I used to hear people say, not so much anymore, but the cloud is just someone else's computer. And I realized after going to an AWS event when I listened to how they were doing their updates to their software and doing it very dynamically, incrementally, because you had such elastic resources. I'm like, okay, now I get it. It's more than just someone else's computer. But I don't know if database has stepped into that world in the same way. There are a lot of online services for data kinds of things, NoSQL, et cetera. But we have a lot of mission critical applications still running in mainframes, running on SQL based, mini computers, if you want to call them that, servers, et cetera. Tell us, how do you see the state of mission critical applications that organizations run on some of those platforms, and where are they in thinking about moving to the cloud?
Yeah, it's a great question, Mitch, and a really good place to start, because I think ultimately we're all just starting that transformation, or that migration of some of these more kind of traditional legacy workloads. Is this, look at, man, like our money, the nuclear codes, anything like mission critical in our lives is still running on kind of these, like, it's like DB2 IMS and these huge massive Oracle instances that are running on, maybe they're on Sparks. I don't know. Geez, man. But these things are dependable, they're reliable, they work. And I think we're only just scratching the surface of these workloads moving to the cloud, because they're just too risky to move. And I think that's where a lot of organizations are starting to try to sort out, like, great, what's my risk versus reward? You talked about how, the cloud is just a bunch of other people's servers. Well, actually, that's true. And there's value in that, because I think people have moved to the cloud because the CapEx versus OpEx equation from a spend point of view. And if you aren't familiar with that, it's just the way that accounting actually writes down servers you buy or servers you rent. And it's just actually fundamentally a better way of thinking things through from a financial point of view. That said, I think people want to get to the public cloud. They want to actually get to this end state. But the running these technologies in those environments is a significant amount of risk for them. Mm-hmm. And I think, when it is a mission critical type workload where your whole business is run on it, yeah, I think people are conservative. So if you ask me, like, how far are we, I think we're just really starting down that path. And there's lots of challenges to actually moving to the cloud for these things.
Yeah, it's a different story when you're starting greenfield as a startup than it is necessarily when you have, mission critical applications that you consider what's the right path and how do you get there. One of the things I think about in with data is, applications are about setting up the environments and how it's configured and the architecture. Data is a different beast, and it's not, rarely is it in a steady state. It's temporal. And I think I've heard you say before, it's also location based, which makes a big difference. And are you going to move massive quantities of data into the cloud all in one step? It's kind of hard to do an incremental move to the cloud with data that's on mission critical applications. Is that your experience?
Yeah, absolutely. And I think, we're starting to see the advent of people very carefully moving chunks of data at a time, using databases that can actually do that for you. Something that we once thought was not even a dream is happening. Mitch, we've got, I got to talk about Cockroach DB here, because this is kind of one of those unique things that we see people using us for. I mean, you can now deploy, a single logical database across multiple different clouds, or, on-prem and in a cloud provider. I mean, we can have a single instance of Cockroach running across AWS, GCP, Azure, and on-prem. Like, ask any node in any one of those instances, and it's going to be able to find the data across all of that. Now, that's pretty cool. Now, if you're going to do that, this movement of data is something that gets really interesting, because cloud providers love it when you push data into them, right? Because that's definitely what they want, right? Let's get vacancy down in our storage layers, right? Like, what they don't like is when you move it out. And so, do you have the context in place to tie data to a location? That's something that people use us for all the time, in these kind of instances. And then how do you manually change where data lives so that you can actually selectively move data, say, from one environment to one like, let's say, a cloud provider to on-prem. For us, it's a simple change of a table. It's an alter table command. Alter table, and it's at the row level. So only certain records are going to be, you can actually geolocate data. You said something interesting in the question, Mitch. It's like, yeah, I think we used to think about all data needs time. And I remember a good friend of mine, Sean Connolly, who ran strategy at Hortonworks, he used to talk about this all the time, because I love that concept, right? Just keep appending, like never overwrite, like being able to select star from table at a particular time. That's pretty cool, right? I just believe that as the world becomes distributed, as we move to the cloud, as this concept of this distributed mindset comes into play, the understanding of the physical location of data becomes extremely important. And, when I first kind of shifted into this kind of distributed world, that was the one thing that I had to really think about, right? That was we think of the logical model of data, but what about the physical model of data too, and where that's going to live? So, and I think that's another one of those challenges. I think as you stated at the very beginning of that question, Mitch, I think for net new greenfield stuff, it's a lot easier to think through. Migrating stuff, hey, by the way, if anybody ever tells you migration is easy, just, I don't know, laugh, like that's insanity, right? So I think we're seeing the net new stuff kind of go in this direction.
Yeah, I think it's Hervé, if I understand his name pronounced correctly. He's saying, startup doing greenfield, we're so already on the cloud. Yeah. It's great to start there. When you don't have any ties to something you've got to convert from. Totally been there myself too.
My question right back at you, Mitch, how many net new workloads are going to Oracle at this point in time? I don't know. I would love to get insight of that. I don't know.
Yeah, I don't have any data myself for that. It probably comes down to, if you're already in it, are you moving new things into other technologies, or are you still adding on to what you have? That's always, a path decision to make. Right. I posted a question to everyone in chat, so I really would love to have everyone respond to this. We're not going to pop up poll questions and, play Jeopardy music. I posted a question in chat. How aggressively have you moved your mission critical databases to the cloud? We'd love to hear from you. Like Hervé said, hey, we're already there because we're greenfield. We could start that way. Any folks in transition still trying to figure that out, post your response in there, and we'll try to use that as part of our conversation. So one of the things I'd love to hear from you, and given Cockroach Lab, your focus on these high volume transaction mission critical applications, what are some of the requirements maybe that you focus on more heavily than you might normally see in what a cloud provider might provide for part of their in-cloud service for a database or things like that? What's different?
Yeah, what's not different is SQL.
Mm-hmm.
I'll just start there. I think it's kind of one of these, maybe I'm just old school or something. I don't know, man. Like when I think of data, I think of normalization. I think of, data modeling. I think of joins. I think of referential integrity. I think, first of all, I think that's what's not different. And you think you kind of got to start there because, we're talking about these operational workloads that are kind of running businesses. And to me, maybe we'll talk about SQL a little bit later again, Mitch, but I think you kind of got to start there. What's happening though is, I think people are looking at our legacy technology and they're running it into the cloud, but they aren't re-architecting it to actually take advantage of the cloud, right? Like I think like this CapEx thing, the having instant compute up and down, like, that's all interesting. We still really think about vertical scale when it comes to a database, right? Like let's just throw a bigger instance at that thing. And when it runs out of time or runs out of space, let's do manual sharding and let's shard that database. And I think, we're still left in this world where, okay, what does it take to manage two instances of a sharded database? Or maybe it's 4 or 5 or 8, the operational resources to actually deal with those sort of things still exist in the cloud, just as they did on-prem. And I think it's let's re-architect that out of the system. Let's architect scale into the system. And that's kind of this distributed mindset. Like this is kind of what, Google has been doing for the last 15, 20 years, right? It's like, make scale part of the solution, not something around it, right? And I think number one. Number two is also architecting for resilience. I mean, if you're going to use a cloud database and you say, oh, it's always on cloud services, well, I tell you what, first of all, cloud providers go down, regions go down, AZs go down, racks go down, and servers absolutely fail on you.
I think Facebook would back you up on that.
Yeah, but hey, whoa, apropos. I don't think that was servers. That was like a manual configuration.
Awesome.
Was that just a wonderful train wreck in slow motion yesterday? What? So,
ouch. Yeah.
Anyway, there's a lot of great memes, by the way, Mitch. Thank you for bringing that up. But if you think about resilience too, like we have lived in this world of active passive systems where you have a primary and secondary, and when the primary goes down, the secondary comes back online. Okay, what's your time between primary going down and secondary coming back in online? Okay, did I lose data? What is the difference in that time? And more importantly, secondary runs for say an hour or two while you get the primary back up and running. How do you bring these two back together and mitigate and remediate the differences? And so, the challenges there are just tremendous. I mean, think about GitHub going down for 8 hours about 3 years ago. Think about the time it took for them to kind of mitigate, and remediate two versions of a database. These are failed. They aren't failed. They've worked for us. I don't want to say they're failed. Like, there's just a new way of thinking about these things, but it takes re-architecting. It's like, for us, it's like, what's an active database? How is every node active? And how do you use distributed principles like Raft and distributed consensus protocols to ensure that transactions are going to be correct all over the place, right? Like, can I access every endpoint of the database and have it able to access the data? Can I store data in different locations so that I can survive a complete regional failure or a cloud provider failure? We have customers doing that right now, right? And so I think those are the concepts that kind of have to be rethought of in this cloud world. And that's why the old world kind of databases, lift and shift, move and improve, aren't re-architect and rebuild, just aren't built for this new world.
I think it's a really good point. And I've kind of learned this over and over. You think about going into the cloud, you think about what we might normally think of as a distributed application living in our data centers. If we have multiple around the world that are on private, in the cloud, you're still talking about things like data replication. You're still talking about distribution of data. You're potentially putting data at different places because of localization for performance, right? Keep the data close to the edge where people are, synchronize it, et cetera. So it is an architecture question. I think that's something that data people, I don't know if they're still DBAs anymore, but data people think about data like security think about security. It's protecting the integrity of data, right? What's more important than the immutable atomic transactions and the integrity of the data. And you've got to come up with an architecture, that not only can perform at high volumes, but as you said, resilience. It's got to be recoverable and it's got to be accurate. Yeah.
And I honestly, there are DBAs still around, by the way, and they still think about these things. I think I'm looking at one,
Used to be one.
Exactly. Right. But it's, let me add, how many developers actually think about isolation levels? Name a developer. Like, when I coded, are you kidding me? I don't care about non-repeatable reads or, like phantom reads. That was a DBA problem to deal with. Developers don't want to deal with that, but I feel like DBAs sure are concerned about that, right? Because it depends on the workload. How correct do you want that data? And what's the trade-off of isolation versus performance? These are the things that I think, I don't think the developer ever wants to think about that. But you're right. The DBA and the people who run that workload, they are very, very concerned about those sort of things. They're concerned about resilience, and I think they are architecting how and where data needs to reside. We talked about locating data in a location from a performance point of view. I think that's one of those things, like cost-based optimizers to make sure transactions are actually running correctly and efficiently, right? Well, think about the cloud and think about the ubiquity of the cloud and the promise of global. Is that a promise or is that a reality? Well, in reality, what's out there is these like data sovereignty laws that are making people kind of respect, the individual characteristics of privacy legislation in each corner of the world. Can German records live outside of German servers? These laws have teeth. So I think the modern challenges as we shift to kind of global cloud providers and all these things, I think they actually just get exasperated. I think there's even more concerns for the people who are architecting our data systems.
We had a variety of responses to that question of where are you kind of in your journey, everywhere from not even there. We're trying to understand the risks. We're gradually moving there. I go there as fast as I can, as long as there's not a DBA admin in my way.
I love that answer. Thank you, Rohan.
Good. Yeah, that's fantastic. I've been there, done that, right? What time do they go home from work? And folks that are already, completely all in the cloud. And one of the, I think, interesting aspects of this too is Christian asked the question about backups in the cloud. That's actually how one of the first steps I took to getting to the cloud was replicating backups instead of doing things to tape and disk and like that, and just using the cloud as a backup, but also what's your backup strategy in the cloud itself?
Yeah, I think it's look at in order to go into production, all those key capabilities of a database need to be there, right? Backup and restore is one of them. Like the management, the security, the administration, those things have to be there. Backup and restore is kind of one of these things that it has to be in place. And can you back up to a moment in time? Do you have those kind of capabilities? And I think those are questions that most databases provide that today. And if they're just running in the cloud, then it's kind of a local backup that you're kind of configuring for. I got to come back to the kind of the modern challenges in distributed systems and cloud. If you're running these things in multiple different regions, let's say I have, an instance of, let's say, Postgres in the US and one in Europe, and I have it charted based on locale or something like that. Mm-hmm. If I'm going to back up that database, am I going to back all of that to a location in the US or a location in Europe, or am I doing both in different places, right? When we start thinking about these jurisdictional control and speed and access of data and the speed of light, well, distributed backup and restore is what kind of the modern way of thinking about these. I think, this distributed mindset really is critical across all these things. I think about, if you think, Mitch, through the past 20 years, what have been the goal of IT? And I don't care if you're a DBA, a developer, on the business side, you're in system tests. I mean, we need to get to production quicker. We need to lower operational costs, right? We need to increase our developer productivity. And ultimately, we need to improve customer experience. We have been chasing those four things since the dawn of time. That is everybody's thing. And I don't think we've made significant advances in those things until the last 5, 10 years.
I think our first ISAM database, we've been worrying about that, right?
Exactly. But
way back.
Yeah, that's right. And and it really comes down to it. If you really, really break it down, any goals of any organizations come out of those four things, right? And if you think what we've done over the past 4 or 5 years in terms of changing the way we think about the software development supply chain, starting with containers and how we've containerized things, we put them on, we can put them on a truck or on a boat, and literally the containerization, so that we don't have to, build for Mac or Windows anymore. Remember games, you buy the wrong version, simply being able to do that, and now orchestrating that at scale. But underneath, having, code repositories and Git and Jenkins, and being able to use Terraform to provision my hardware. And then once I'm there, I'm using Kubernetes as the orchestration layer. And this automation that we've placed into this supply chain to get our apps from, the codes of the fingers to, the code in the fingers, from the keyboard to in front of people, that has just fundamentally changed the way that all of this stuff works. And I think, to me, the database is part of that infrastructure. In thinking about the database in the same way that we think about this automation, how do I automate scale? How do I automate resilience, right? How do I automate this kind of location of data and these sort of things? I think automation is kind of one of those things that, this advent of the SRE out of Google, right? It's no longer DevOps, it's SRE, right? And it's right, because we're talking about things in terms of objectives of the organization and what that actually helps. I mean, automation is going to fix a whole lot of things. I mean, if you think about, somebody told me at one point that Facebook Messenger runs on, it's something like 100 shards of MySQL.
Wow.
Yeah.
I haven't heard that.
Yeah, right? In I don't know the exact number, and forgive me if you're from Facebook and you've woken up today after getting drunk last night, I guess. But just think about the number of people it takes to manage just that, right? Well, what if we could just automate that, and you have, 100 instances of a distributed database? Where can you take those resources and use them in other places? Mm-hmm. Those are the type of efficiencies that these levels of automation that we've introduced into the supply chain are making radical changes for organizations. To me, honestly, that's what I'm most excited about over the next 5-10 years, to see where this all goes.
Rohan said, I think I just died a little inside hearing that.
Oh gosh, right? Yeah, right. Like, think about that. Like, this craziness.
Well, it's an important, and I'm going to get to some of the comments too that folks are making. I think it's an important factor. One of the benefits of DevOps is that originally it was supposed to developers are going to do everything. We don't need anybody else was kind of the mantra. I'm so oversimplifying, and what it really has done is elevate the importance of basically all aspects of what we do, from ops like SRE, security, shift left, DevSecOps, data ops, things like that. But to your point, the reason why I mention all this is the driver behind all this is getting software out faster, because software has gone from back office to business strategy, right? We can't do a VBRO without software being front and center. You can't do a digital customer experience without software front and center. So the pressure is on everyone to get everything out faster. And you can't do that manually. You can't deliver software into production multiple times a day through manual process. Just ain't going to happen.
Right.
So that automation is key. And I think one of the challenges in a data mindset, data world, where I can't just roll back the DDL, the structure of the database, because we decided to roll back some changes. I've got to kind of keep rolling forward unless I'm doing some recovery of some type. So it's not an easy task for data people to take this on, all the automation.
Not at all. And, but where does it land in 3 to 5 years, Mitch? I mean, for us, look at, like, as a company, we just believe in making data easy. Like, from day one, when I first got here, the founders told me that. I was like, God, data is never easy. But if you think about it in context of, like, the people who interact with the data, if you think about the developer, how do I make data easy for the developer? And if you think, like, take everything that's happened to date and then start to kind of, like, think through kind of where things are going to be, extrapolate 3 years out, 4 or 5 years out. And you think about this move towards serverless. And what does that mean? What does the concept of a serverless database mean for people? Right? It means a developer can just spin the thing up. They don't have to worry about scale. They don't have to worry about resilience. Sound familiar? And they want consumption-based pricing. But for the provider, it means I need to spin things down if they aren't being used. It needs to be multi-tenant, right? I need to conserve on the back end. But it comes to the point of, like, we need to minimize the amount of compute that we're actually doing. And so I think the ultimate end game for automation, we end in this world of serverless. Now, what does that mean? Well, the database provider has to provide all the DML and all the commands that is going to allow the developer to actually take care of the things that you're talking about, rollbacks, online schema changes, like all that stuff. Like, the developers have to, as long as they have access to that, can they start to think about those sort of things? And ultimately, what does the database become? To me, the grand vision of, like, the dream for the developer, it's a SQL API in the cloud. It's the same way that we code against Okta for authentication, or Twilio for the amount of things they provide for developers. Can't the database just be that eventually? I think it's a pretty radical thought. We're doing it. You know what I mean? Like, and I think that ultimate simplicity and the ultimate ease, and the consumption model, which the developer wants, because ultimately, dude, the developers are the ones making the decision on databases today, right? Like, it's no longer like, hey, CTO has this really great deal with Oracle and everybody's got to use Oracle. It's open source databases, it's database as a service. Like, 9 out of 10 developers I know today, if you want to start an application, they're going to AWS, they're spinning up an instance of Postgres on RDS, and they're running, man. And those decisions are made in those moments.
I think that's the mindset we have to change. And someone was asking about, Hervé was asking about sort of modern approaches to cloud databases. One of the mindsets that I would suggest to everyone is, we lived in an era of protecting everything by standardizing on stuff, saying no to everything, all that kind of, the typical IT mantra. And we really have to embrace the change. We have to embrace the speed. We have to embrace the pace at which things are happening. Doesn't mean, that solves it just by embracing it. But every moment you spend fighting something is more time you're not spending doing it and making it happen. So, like, moving to a product like Cockroach DB, I'd love to hear your thoughts about what are the paths that people can take those steps. This is sort of of all or nothing? Do you move some parts of applications as they're being re-engineered for the cloud, or no, don't worry about that part, change it underlying underneath and kind of treat it as a data as a service? Talk about the strategies for how Cockroach DB can fit within that world.
Yeah, I mean, I think you just nailed it, Mitch. I mean, it's really one of those two things. If it's a net new application, spin it up in a cloud instance or use serverless and just start coding against an API. And don't have to rethink the way you code or you think about the database, right? This is still a logical data model. There's a cost-based optimizer. There's actually CDC built into this. It's all the core things that you just want to do. Start coding. However, if you're migrating is never easy. Now, in a modern database, and I think this comes back to the question, it's like, what are the factors holding people back from migrating workloads? It's always a challenge. Now, one of the things in a distributed system, we get questions about this all the time. We haven't implemented stored procedures. Ooh, gasp. Oh my God. What?
Be careful.
Like, really? Who wants stored procedures, dude?
Yeah. That has its own challenges.
Right. They do. And they were invented in a time when we needed them, because you know what? The database servers were huge. And that was the one place that we can actually run a service. It was a service is all it was. It's an anti-pattern for the modern world. Like the modern world is like, okay, run that as a Lambda function or some, microservice running in.
Put it in a container as a microservice, run it somewhere.
Exactly.
And let it change 50 times over the next 3 months, because that's what it needs to do.
That's right. And it's in a language that I understand. There's a team of people who can work on that. I can check it in and out of my version control system, Git, and all those benefits. I think the one area where stored procedures were very, very powerful that maybe you can't architect that back in is, do you remember, we used them because we only wanted to control certain functions had access to them, from a security point of view. Mm-hmm. That's the one thing that I think, I still see that as a valid, but you can do that with authentication to the service. And it's just I think it's a little bit more complex. I think you're giving up, but the stored procedure, it's an anti-pattern. Mm-hmm. So I think it's you don't really have to rewrite the application. Maybe you have to put retry logic around things, which you should have been doing anyway in your apps, because in a distributed database, you're gonna get conflicts because people are accessing from multiple different places. You have lots of endpoints, all accessing a single logical database. So I think that's one of those things. But I think the third and the largest thing that people have to rethink when they're re-architecting an application to be distributed is this physical location of data and what that means in the database. Because think about a query. Sean Chittenden from DoorDash. I was on a webinar with him. We were talking about this. What was one of the things that people had to think about differently? Think about an insert of 10,000 records into a database, right? Pretty simple. Insert. Here's the records, and great. Execute. Database takes care of that. Well, what do you do when you have, multiple instances of a database and it's all distributed and actually can be, pushed? Do I do 10 inserts of 1,000 records across 10 instances? So sometimes you have to think about the way that you're coding and the way that you're interacting with that database in a different way. And that's something that, I think we see a lot of organizations going through this kind of a shift to a distributed mindset. Mm-hmm. It's that paradigm shift is really tricky, man. And I think that's one of the biggest challenges. It starts with operations, but eventually the developer actually picks up on it and says, "Oh, I got to think a little bit differently here."
Well, it's shifting from what we used to call sort of the big iron mentality, right? Right. It's all in one big place with lots of speed and power and et cetera, and more to a distributed partition shards of the database. Some really good questions in the chat here. Paul's asking about, and I agree with you. We live in a developer-driven world, or more appropriately, a software availability, the kind of democratization of software. Anybody can go with a credit card and get onto a cloud, start doing something in a data service. Anybody can download your open source for Cockroach DB, start using it. Could be in IT, could be outside of IT. In this developer kind of world, how do you let developers just do whatever they want inside the database and the structure of it? Maybe they're not data experts, or can tools help guide that? How do you live in that kind of world? What do you suggest?
Do you let developers just do anything anywhere? No, hell no. Provision.
But they'll do it anyway.
provision and authorize to do what they need to do, and authenticate and authorize, and then hold them accountable. AAA applied here, right? Like in the, as with anything, I mean, you're going to have architects and you're going to have developers. They're very different people. Well, they're actually the same person, but one actually thinks about these things.
Just a different hat, right?
Exactly. And the people who get it, you provision them to actually allow them to do those sort of things. I think that's the trick there. It's just, sometimes you want to allow a developer to do some interesting things. So they might think of things differently. One of the things we could do in our database, like I said, I can alter a table and change where data lives based on a column, right? Like I want all the records in Germany to live in Germany. Well, what if I spun up a couple of new instances and they're in Portugal? I want to take those records that were all my EMEA ones. They're in Germany, but I want them to actually be now in Portugal. Well, it's an alter table command. Like who has access to that is the question here. And I think, do you give them access and allow them to think differently and dream of new ways of using the database to provide capabilities? That gets really interesting. I was talking to somebody about you think about, control of where code lives in a backend Git repo. Wouldn't that be cool as an advanced feature, and being able to change that on the fly as an end user? That'd be pretty cool, right? Like, look, I got my devs in San Francisco all accessing this part of my code base. We've got devs in India reaching this one, like get all one kind of Git repo. Be pretty cool, right? Underneath the covers, right? And so you start to dream of different ways to do business. And I think abstracting those things away and not allowing them to think through them is a mistake. But giving them just outright access is also a mistake, right? Because you want people to dream and think differently.
Yeah, you want them to innovate, and they're going to come up with ideas. We always live in this world. You never imagined somebody might use the data that way or want to do something with it.
Yeah, and modern tools allow you to think differently, and that's the point, right? Like it's if I sat there and we never had this, like that's just the tool. We thought of worlds of things to do on that. Same concepts, yeah.
One of the things I would share with folks too, we live in a world where anybody can create applications, right? Low code, no code, or go build something in the cloud, build it out of Python, whatever it might be. And one of the interesting things I've observed over time, there's virtually no application is an island. Almost never is an application kind of live on its own with its own data, never talk to anything else, right? And almost invariably, most, if not every application will come back to needing one of three things. We need security, could be single sign-on, could be tying into other policy-based tools. It's data, and it's integration with our other apps, right? And we live in a world where we have to synchronize the release of software, not just in one greenfield app, but across a mainframe, a cloud-based, or on-premise, new database, old database. So the good news is, why I'm saying this is, don't think about it from a scarcity mentality. Oh my God, what if they want to do something else? What are they going to come up with next? You want them to come to you. You want them to say, I'm trying to figure out how to do this. I think I'd like to copy the database to live in India. And you can say, well, let me help you with that. Actually, here's a great way to do that. We can make that happen. Poof. You're in the middle of helping make it happen instead of being please don't, how do I shut off my email for a day so they'll go away?
Right. And but the database vendors need to make it simple for people to do that. That's the problem, Mitch, right? Like it goes back to the very first question, like legacy databases in this modern world don't allow you to take advantage of what the modern world actually provides: scale, resilience, and ubiquity. Your example is ubiquity. Like, for us, well, spin up a couple instances of Cockroach in India and point them at the cluster, and the database is now distributing that workload. Now, every single node is an endpoint to the entirety of the database. I could ask any node for the data, and it's going to find it, no matter where it's at in that cluster. That is a different way of thinking, right? And that, so you don't have to be afraid of that. You don't have to shut down your email for a day because you don't want to be bothered, right? Like, oh, let me spin up the instance and get it going. Okay, great, you got it. Are you minutes or are you days from that? And again, it comes back to, how does automation allow us to rethink the way where we're applying our attention as DBAs or admins or DevOps or SRE? Like, how does it allow us to actually focus on the other things? because I think like that's what automation allows us to do. That again, that's why DevOps became SRE. They started thinking about things about scripting and doing things in another way so they can actually free up their time.
Mm-hmm.
Add complexity and more free time. Wait a second, what? And that's the kind of thing.
Yeah, there is. I mean, it's a different world where there is no post-release. We're always releasing.
But
right?
No, it's consistent release. I mean,
yeah.
Mitch, have Launch Darkly?
Mm-hmm.
Yeah, a little company. You feature flag. In fact,
absolutely.
I would release to 5 users if you want. You know what I mean? Like it's just I'm a marketer, dude. Right? So what is a major product launch these days? I don't even know how to even think about that anymore. You know what I mean? Like you're constantly releasing.
So many things aren't all or nothing anymore. I want to ask you about multi-cloud. Talk about multi-cloud being across different cloud providers from a data standpoint. What are strategies? How would you deal with that with Cockroach DB?
With Cockroach, it's again, we think about what is a region but a cloud. I mean, yeah, okay, so you have kind of one network backplane that you can kind of take advantage of within a particular cloud provider, but there's tools out there to allow you to do that today. I mean, there's like things like I know in the Cloud Native Computing Foundation, like there's a couple of projects, like I know Scupper is one of them. The guys at Cilium, oh my God, I'm totally flaking on the open source project that they have. There's a bunch of guys that came out of VMware and the whole network defined networking, right? Like that whole group, or software defined networking, the SDN side. Okay. There was a group that started a company called Cilium. I forget, there's an open source project, but people are using that to actually, mitigate the problems of the network layer between the various different cloud providers. Again, huge challenge. Networking and security are the two big ones that are stopping anything from a kind of multi-cloud point of view. We're doing it today. We're in production. One of our customers, Form 3. Oh my God, we have 5.9 and Form 3. I mix them up all the time. So it's Form 3. They're over in the UK. They have this basically a transaction clearinghouse for the UK banks. Okay, there was this whole like regulation that came into place, and they want to be able to survive the failure of an entire cloud provider. Mm-hmm. And so they're using us in production today with hundreds of thousands of transactions a day, money transactions, right? Like guaranteed, consistent, serializable isolation, like for their transactions across 3 different cloud providers. And they're doing it today, and they're using. I'm totally flaking on the name of the project from.
I'm not ringing a bell either. There's
it's
good things.
CILIUM. That's the company. I forget the name. Oh, is it EBPF? I don't know. But there's a couple of things out there if people want to go check it out. There's a lot of kind of work in this, to solve this networking. The other problem is this whole the whole what's a control plane? What's a common control plane across Kubernetes providers? That's another one that I think people are starting to solve. Like the Crossplane group that's run by the company called Upbound. I think they're doing some really cool work. How do you manage multiple Kubernetes clusters and that sort of things? There's things out there. They're emerging, but some of them are proven in production. Like I said, we have customers today doing that.
Yeah, I'm going to pop a question into the chat. We'd love to hear from you of kind of how do you choose a database technology and thinking about where you are and what you want to move to. There are people who can like, okay, good. At lunch, we're going to Google something and go download it when we get back to our desk or at our house. Others will have to go through this whole company approved process, or there's a selection kind of project. I'm interested in from our audience, please jump in because we want to talk a little bit about this, because we lived in this democratization of software, but there's also guardrails. There's sometimes things that stop us at different points. There's sort of ways around that, all those kind of things. And sometimes it benefits, somebody like a Cockroach Labs, and sometimes you need to work through those processes, right?
Yeah. You mean, how are people choosing, Mitch?
Yeah. How do you?
It's look at the RFPs that I see today are the same RFPs I've been seeing for years. It's the same categories, you know what I mean? Like, but that's at the top level. But I think where a database is getting chosen is in the developers. Like they're going to go out and choose the thing that they just want to use. And you know what? There's a lot of developers today are really comfortable and fortunate to be able to use Mongo. They learned that in college, so they're using that. Did you know they don't teach a SQL course as a kind of standard in college courses anymore?
I did not know that.
In undergrad. I couldn't believe it when I heard it. Like, I just, it befuddles me because I think, Mongo is great tech. I can't say anything bad about it. Is it good for multi-cloud? Is it good for transactions? Does it actually deliver the like this document model versus the I don't know, normalization and the database form, right? Like that sort of thing. Like that's a whole other topic. I think the choice of databases is happening, especially for net new, in the mind of the developer saying, I need to build something, go spin an instance up. And they're looking at it and they're saying like, yep, there's open source databases. There's these existing databases. What are the things I need to solve? Our challenge is to make sure that people, when they look at Cockroach, they consider cockroaches. This is just SQL. We're wire compatible with Postgres. This is literally the same SQL syntax. Wire compatible. I spun up an instance of our serverless and I ran it against one of these low-code platforms, Retool. Retool's great. It's a bunch of guys who built this kind of internal tooling thing, and I just used the Postgres drivers, and it communicated with Cockroach, and I was off and away. It was the same DDL and it was the same syntax. What I don't have to worry about with this now is the concept of scale, this concept of resilience. So that decision where it was once made by a central group when I choose a database in the CTO's office at scale for the whole company, now that's being made by the developer. The developer doesn't even think about scale and resilience anymore.
They don't think about hardware. You don't have to worry about NAS or what you're saying or whatever you're putting this on, and the distinct differences of what those are. I mean, you might have to in a corporate data center, but certainly not in the cloud. There's a question, by the way, Thomas is all over no store procedures with you, so on Oracle. What about data that's got to live for a long time? You need to keep it around. The example, I have to go back and look who posted this. It's Christian was asking about, what do you do for data you got to save for 50 years? Hopefully you're not keeping all your data that long, but there are times when you do need to hold on to information for extended periods of time.
This isn't my world of expertise. I mean, I'm kind of more in the operational data workflows, but for me, I think, offloading that to a cloud provider makes a whole lot of sense because, they are doing distributed storage and they're doing backup on all that. Like, look at, man, I just downloaded, I needed space on my phone the other day. So I took like about 4 gig worth of photos and I put it on my local laptop, but I know it's in Google Photos as well. I actually trust Google Photos a lot more than my laptop because this laptop's going to die. Mm-hmm. Everything fails, man. Like everything fails. So for me, like cloud storage makes a whole lot of sense. And, if it's GCP or if it's AWS, it's Azure, if it's DigitalOcean, like they've all made it relatively cheap to get storage these days. So if I think about like offline storage, well, if your cloud stuff is there anyway, why not? I mean, it's kind of easy to move around once you're inside the provider, right?
And the cloud providers have tiers of storage, right? Here's high volume, high transaction speed, as well as for archiving and that kind of thing. So there are definitely strategies for doing that in addition to the database technology. So we've talked a bit about developers, and I totally agree with you. It's it's a developer's world in many ways. What about the role of open source? Cockroach DB, Cockroach Labs, you offer open source version, you offer a cloud version, etc. In my world, my experience is developers look at it as you either really believe in open source and you're a believer, or you're doing it as a sort of a fictitious, okay, we have open source checkbox, but that's not really what we do. I mean, how do you create a database product strategy that really can embrace the developer as well as the data folks?
Yeah, open source is such a nebulous term. Sorry, like I just I think of open source as really kind of along a couple different vectors. Like, yes, the license is important, and anybody who's like a total open source zealot, if it's not in the OSI, if it's not, an approved open source license, that's not open source technology. I understand that argument completely and totally. We actually do not implement GPL2. We have actually gone towards BSL, which is the business source license, which basically says, look, it's this same license that you're going to expect out of Apache. the Apache license applied to the software with one caveat and for an amount of time. You cannot host our software and make money off of it as a pure database. So what is that doing? It's just protecting us from any sort of predatory tactics of the public cloud providers. That's all we're doing. That's all we're doing. Do people use us inside their ISV software and provide their function as a service on top of our data? It's all over the place, man. You bet. There's nothing stopping anybody. And also, we gave a time limit of 3 years. So after 3 years, whoever wants to use it could just use it. But what's important to me in open source is less that, because I think, who doesn't care about that? The companies who are adopting us, they want to use this. They see the value. To me, open source is about code. And if you want a PhD in distributed systems, go check out the code base of Cockroach. They've done some pretty awesome stuff in there, right? Like our implementations, it's all in Go. You talk about an implementation of Raft and production and some of the things we solved, it's all there for anybody to see. And I think that's a big thing. I think the other part about it is consumption, is community. Are there a group of people around us that are actually contributing and talking and dealing with us? And I think that's on, these communities to build. But then the third is consumption. I think that's what you and I have thought about from an open source point of view for years, Mitch. Open source, when I was at Hortonworks doing Hadoop, it was open source. People just go download it and start using it. That's cool. Well, there's been a fundamental shift in the way that we actually consume software, right? Y'all, we now want these things as a service, because I don't want to prop up a server. I don't have a box underneath my desk. And so this concept of open source is no longer download and use. I want to consume things as a service. Mm-hmm. For us at Cockroach, we want to return that free to open source. That's why when I talk about a serverless database and us driving our costs down, well, can we make it free to a certain level of consumption for people? We want to have a forever free version of our software where you can run some pretty decent applications on that. And that's returning the free to open source. Mm-hmm. And I think that's gonna, to me, that's one of the things I'm most proud of here at Cockroach Labs, being kind of, I don't know, in this open source game for really quite some time. But I think open source is always a complex conversation, Mitch.
It is, and it's evolved over time, to your point. And I think you highlighted a couple really important things, several. One of them was community and engagement with the developers who are creating the software. If you're not, you don't have to be, an open source developer contributing to the project. You can still engage and follow along and test, and whatever role you want to play. You can lurk if that's what you like to do. And to your point, there is a segment of the world who wants convenience, right? If I don't have to go through the whole process of setting it all up, I'm happy. Other folks I want to see it. I want to see how all this works. I want to go look at the code if I want to look at the code, right? So you've got that strategy. And you have other folks that are totally turnkey, just turn it on, I'm going to use it. So I think you have to not just cater to one, but satisfy, in a meaningful way to all those audiences. We have a few minutes left. I'm going to announce who our gift card winners are in just a moment. So please hang around, everybody. Let's finalize our conversation, see if we can take this out on a couple of themes. Security, that used to be a reason not to go into the cloud. How do we think about security in a distributed cloud world? I know that's got to be a key part of what you all have thought about in your product strategy. And then how do I get started? What's a good way for me to engage with Cockroach Labs and Cockroach DB?
Yeah, so security is a good one, and I'm happy it came up. To me, the concept. Remember back when open source started, we're like, oh my god, you can't use that. What about the security there? I don't even know what's in those libraries. Oh wow. And so there's FOSSI, and there's a couple organizations that allow you to inspect and understand what's going on. So security came a long way in open source. Ultimately, I think the beginning of the cloud, also people were like, oh my god, I can't move to the cloud. I don't know what security. Well, ultimately, what ends up happening is you get the security as best practices put around the managed instance or the managed service. For Cockroach, we know our database really well. What we didn't know about 3 years ago was how to actually run this thing at scale in a cloud provider. And by running this as a managed service ourselves, hundreds of thousands of clusters on Kubernetes, oh boy, did we learn best practices around how to secure this thing. And so you're relying on vendors who have made it simple enough to either, just trust it that it's going to be secure, But also, more importantly, does it integrate with the tools and the systems that you have already implemented? And I think for us, it's both of those sides. And I think the third thing here is it actually allows you to do some really interesting things here, Mitch. And by working with big customers, like this is where you learn this distributed mindset where you get to security in a different way. Distributed system, one of the core concepts is this thing called a rolling upgrade. I have different nodes of Cockroach. I have 10 nodes. I could take a node down and bring it back up on the next version of the software. It's going to work within the context of that. What does that mean for me from a security point of view? Well, think about how you apply patches. Think about each node and the hardware it runs on. Can I just repave my entire server farm? Take the entire server, reimage the entire thing from scratch, and now bring the software back up, point it back to the cluster. The cluster saw no impact in production. This is no downtime. And so you actually allow, like I said, distributed mind you start thinking differently about features. You start thinking differently about resources. You start thinking differently about security, right? And I think those are the things that this distributed world starts to allow us to live in a different world. But it's the systems underneath that are built. Getting started with Cockroach is pretty easy. Go to our website, click on Getting Started. You could spin up an instance of Cockroach DB dedicated today. Give me a week and a half, and we'll give you a free instance of Cockroach DB serverless as well. And so, as a developer, spin up a cluster and start coding against it. Get a connection string, configure your drivers, whatever you want to do, and you'll be coding against this thing in moments. So it's pretty easy to get started on Cockroach.
Yeah, it really is. And, I think what encourage folks to do is talk about the distributed and the security of that. There's trying to make what you're using do those things, which can be sort of, jumping through hoops. And it's a different story when you're working with a product or technology that is designed to do that.
That's right.
I think that's one of the differentiators, in my looking at Cockroach and also the rest of the market is you may not be a distributed expert as a DBA or as a developer or whatever role you're playing, but you can come up to speed and start to leverage, test, try, experiment, et cetera, with those kinds of capabilities in the cloud, et cetera, with a technology like Cockroach DB. So it doesn't have to be I've got a huge leap of learning to get there versus I can learn there by doing, as well as, the learning that might go with it. So that's another, I think, a big advantage that you offer to folks.
And Mitch, I appreciate you talking about it in the context of Cockroach database. And yeah, we are one of those things. There's a world of these kind of modern distributed technologies that are allowing people to do that at every layer of the stack. And I think to me, that's what I'm really most excited about in this part of my career. The entire stack's being transformed. Is the data a big piece of it? Yeah. And do we have a play in this? Yeah. And we have a definitely, but I think at every layer, we're seeing this stuff happen. It's fun to watch.
It is. There's some other great questions we didn't get to, and I just would suggest Dan is talking about the experience you already have with RDBMS. That's the advantage of Cockroach being SQL based.
Right. And amen, Dan, right? Like, we moved away from relational because we wanted this NoSQL thing because we needed, but we took the guardrails off of transactions and we got rid of the data model. Well, that stuff is important. Well, funny enough, technology continues to advance every minute, right? And now we're basically saying, let's take relational. Let's take all the concepts that are great in NoSQL and combine that. Let's get serializable isolation, distributed, global reads and global writes through every single node, guaranteeing, sub 20 millisecond access to every transaction on the planet. Like that's awesome. That's RDBMS. And you're still going to have joins. You're going to have referential integrity. No more of this crazy document model craziness. I'm sorry. I can't.
There's a place
I'm
for
not
those,
a fan of the
for
document
different
model.
approaches. Yeah, there's a place for different approaches.
I know. I never
understand your bias.
I dropped off at XML somewhere. I just was like, I can't,
Well, let's wrap up. I want to announce our gift card winners. Our 4 winners, and the folks at DevOps.com will reach out to you to tell you how to get hold of your gift cards. It's Juan E., Rodell M., Luke L., and Barbara H. So congratulations on being winners. Well, as a former DBA, it's great to see from Stonebreaker to today how far we've advanced in how many things have carried forward, but also how much innovation that's happened. I want to thank you, Jim, who's a product evangelist with Cockroach Labs, and Cockroach Labs for sponsoring our webinar. It's been my pleasure to be with you. I really want to thank our audience. We've had some great participation. It's driven 80% of our conversation. So thank you very much. Hopefully that helps us answer your questions. And whether it's Travis or Mario, Christian, Hervé, Thomas, all of you, thank you so much for participating today. Jim, thank you very much.
Yeah, that was great fun. I was just typing in great fun into the chat. Mitch, seriously, I'd do this anytime with you.
I'd love to do it again.
And thank you to the audience. There was really good questions in there.
Great. Everyone will receive an email with a recording to the webinar. Please feel free to share it with your friends. And we look forward to being with you on another Cockroach Labs and another DevOps.com event. Take care. We'll talk to you all soon.